Okay, good evening, everyone. So we'll start our second session. So in this session, we are going to discuss about the nearest neighbor-based classifier. So it is one of the very popular classifier, but we should know its different variants, which can be applied to different research domains. So although the concept is same on all the algorithm variants of the algorithm, but the way they select the neighbor is different. The concept of NN is there in all the variants, but uh, the way they are picking the nearest neighbor is different. So what we are going to discuss in this session, we'll start with a simple nearest neighbor algorithm. Uh, Normally, here we consider only one neighbor. Then we'll see about the different variants of the nearest neighbor algorithm. We'll start with k nearest neighbor algorithm, in which instead of finding only one neighbor, we are finding k nearest neighbor. Then we are going to discuss about modified k nearest neighbor, so which is a modification over the KNN algorithm. Although in literature you can see most of the researchers they apply KNN algorithm, but nobody has applied MKNN algorithm, where the performance of MKNN algorithm is better than the KNN algorithm. Similarly, people have introduced the concept of fuzzy logic into KNN algorithm. They call that as a fuzzy KNN algorithm. Another variant of NN algorithm is called as R near neighbor algorithm. So in fact, in the last year also, we have also developed one of the variants of the nearest neighbor algorithm, which performs better than some of the variants of the nearest neighbor algorithm. Apart from that, we are going to discuss some of the efficient algorithms in this session. We'll see the branch and bound algorithm. So mostly you can see this algorithm is also referred as a very popular algorithm in the field of computer science, and cube algorithm, and searching for the nearest neighbor by projection and ordered partition. So these are some of the efficient algorithms people have developed over other variants of the algorithm. Okay, so let us start with the very basic algorithm, nearest neighbor based classifier. So the main job of classification is that there are some, as it is a supervised learning, its class labels are already defined. So whenever a new sample is coming or new observation is coming, so you have to select a class level of that particular observation. Right. For example, in a particular class, I can say we have a section A and section B. Okay, section A is comprises of some students, section B comprises of another set of students. Suppose a new student is admitted into a particular institute or a college or a university, then the student has to either enroll in A or enroll in the B. Okay, so on what basis we are going to alert that student to section A or section B? So that is also the problem can also be solved using nearest neighbor classifier. So NN classifies a sample based on the category of its nearest neighbor. For example, that new student has similarity with another student. Okay, here the meaning of similarity you can consider in a different way. The meaning of similarity may be the student performance is good. The meaning of similarity is that the home location of the student is both student is same, right? Something like that. So based upon its nearest neighbor who is very close to that particular student, okay, then based upon that we are going to assign a particular category. So nearest neighbor uses some, or you can say all the patterns. So sometimes we take all the patterns. So suppose you have 1000 patterns, then you have to consider all the 1000 patterns to select only one pattern. Or some advanced algorithms developed over NN algorithm, which says that no need to consider all the pattern, you can select some of the pattern. Okay. And I'll tell you also how to select some patterns from all of the patterns. So at least you have to take some patterns, okay, in the training set in order to classify the new pattern or the test pattern. Okay, so you have to classify that pattern, uh, the test pattern into one of the class label of our training pattern, right? Suppose training patterns are having X, Y, Z category, then test pattern is either belongs to X or Y or Z. So some patterns you have to examine. Based upon that, you have to take a decision. So obviously, you need some kind of parameters to select something, right? So finding the similarity between the test pattern and every pattern in the training set is very difficult, right? So we have to select some patterns. Based upon that, we have to decide which class level we are going to assign, uh, which class level we are going to assign to a test pattern, right? So if you go for mathematical representation, so I can say you, suppose you assume that you have n training patterns, you have x1, x2 up to xn. Okay, these are the training patterns. And x1, let's say, belongs to theta 1 class, x2 belongs to theta 2 class, xn belongs to the theta n class. Okay, so they belongs to different classes, theta 1, theta 2, theta 1. You can not necessarily that all the test, all the patterns are belongs to different class. Okay, maybe if you have 10 patterns, you have 3 class levels. Okay, so xi is not considered as a single dimension. Sometimes we consider xi as multiple dimension, and theta I is the class level of the ith pattern. Okay, and if you take P as our test pattern, so you have to calculate the distance of P to x1, distance of P to x2, distance of P to xn. Okay. And after calculating the distance of these patterns, you have to find the minimum among them. Okay. For example, I can say this is my test pattern P. Okay. Test pattern P. And just a minute. Okay. If I'm taking a test pattern P, I am taking a test pattern. Just a minute. Okay, if I take a test pattern P, let's say I am taking a test pattern P, and my existing patterns are x1, x2 up to, let's say, xn. So what I have to do, I have to calculate the distance from P to x1, P to x2, and P and xn. Let's say distance is coming, let's say 1.1 here, 2.3 here, let's say 5.6 here. So out of this distance, the minimum distance we are getting in the case of P to x1. So as the pattern P is close to x1, so pattern P is assigned to the class level of x1. For example, the class level of x1 is, let's say, theta 1. So the class level of P is also determined as theta 1. Okay. So in this way, we assign uh, the patterns, the test pattern into one of the class. So we'll take an example to understand this. If you have not understood the mathematical part, so with this example, it is easy to understand. So for example, here I am showing you 18 different training set, right? Or 18 different patterns. So you can see x1 is equal to 0.8 and 0.8 and 1. What it indicates? X1 is a point where its x coordinate is 0.8 and y coordinate is 0.8, and it belongs to class level 1. Similarly, if you go for x10, x10 is equal to, let's say, 4.2, 3.2 and 2. It indicates that the x coordinate of x10 is 4.2 and y coordinate is 3.2 and the class level of x10 is 2, and so on, right? So first 2 represents it is a 2 dimension, and the third point represents what is the class level. So you can see there are 3 class level here. One is 1, another is 2, another is 3. Okay, so total, if you consider the, I can say, the class level, okay, then we consider it is a 3 dimension. Okay, otherwise it is a 2 dimension. So what we have to do first, we consider uh, two numbers in the triplet. Okay, to plot the, I can say, the plot the points in a particular graph, or you can take a piece of paper, and based upon this feature value you can plot, you can point a particular data, right? For example, if you go for 0 0.8 and 0 0.8, so x-axis it is 0 0.8 and y-axis is 0 0.8. So this plus sign represents 0 0.8 and 0 0.8. X2 case it is 1 and 1. So you can see this plus indicates it is 1 and 1. Similarly, 1.2 and 0 0.8, x-axis it is 1.2, y-axis it is 0 0.8. So similarly, you can see we have represented 18 different points into this particular graph. Now, if I ask you these 18 points, except this particular point, this point is actually which I represented with a square. Inside that there is a black color dot. It indicates there is a test pattern. This is our test pattern. So forget about this test pattern. So if you look into these 18 different points, so obviously you will say this belongs to one particular group, this belongs to another particular group, this belongs to another particular group, right? Why we are saying this one? Because by looking into visualization, we can say that the distance between two different data point is less, right or not? That is the reason why we are saying that these data points belongs to more or less their distance is less, so they belongs to one particular class, right? But there is also challenging, right? Sometimes the distance is equal to two different distance is equally the distance is equal to two different class. So there is a challenging, right? Or two different point which belongs to two different class. So it is quite challenging. So here we represent the class 1 is by plus, and class 2 by cross, and class 3 by star. So you can say this is my class 1, I can write C1, this is my class 2, and this is my class 3. Similarly, somebody can represent the data in 3 dimension, because when you deal with the different type of research problems, you can get the data is n dimensional, where n may be anything, right? So in that case, you have to making the group is also very challenging, and visualizing that is also very challenging. That's why data visualization is very important in the data science perspective, which we are going to discuss in subsequent lectures. So now, if a test pattern is given to you, so if you look into the test pattern P, okay, or you represent that is by x19 also you can represent, because you have 18 points. So it has 3 coordinates, right? Like every points we have every data points you have 3 tuple. So here also you have 3 tuple. So its x-axis is 3 and y-axis is 2, and x-axis is 3, y-axis is 2, and the class level you don't know. You don't know what is the class level. Okay, you don't know what is the class level. Okay, so how to determine the class level? Because everything is triplet, right? The class level need to be determined. So in order to determine the class level, you have to compare you have to find the distance from P to X1. You have to compare the distance from P to X2. Similarly, you have to compare the distance of P to Xn. Okay, so in our example case, it is X18, right? You have to compare. And once you compare, how to compare? There are different type of distance measures are there. You can go for Euclidean distance. You can go for Manhattan distance. You can go for Mahalanobis distance, right? There are different distance measures are there. So the very famous distance measure which we are using from our childhood, that is only Euclidean distance. So once you determine the Euclidean distance, you have to find which one is the minimum distance. And suppose minimum distance you are getting in the case of, let's say, xk. Okay, and let's say xk class level is, let's say, theta k. So that is the class level for our pattern P. So what we did here, I am taking the pattern P 3 and 2, and I am comparing with a particular data point. Let it be x1. So P is our 3 and 2, and x1 is 0.8 and 0.8 belongs to class level 1. So if you calculate the distance, it is either you can say 3 minus 0.8 whole square if you calculate Euclidean distance, plus 2 minus 0.8 whole square. Or somebody can write 0.8 minus 3 whole square and 0.8 minus 2 whole square. That also you can say, and it's root over. So if you calculate this one, you will get the value is 2.51. Right? Similarly, you have to calculate that this is your calculating distance of x1 to p or p to x1. Similarly, you have to calculate distance of x2 to p, distance of x3 to p, and distance of x4 to p. Like that, you have to calculate up to distance of x8 into p. Okay. So can anybody calculate up for x18? Right? If p value is 3 and 2 and x18 is 4 and 0.7. So it will be root over of, I can say 0.8 minus 4 whole square plus, okay, 0, no, not 0.8, because our coordinate is 3, 2, right? So I can say 4, let's say I'm taking this one first, 4 minus 3 whole square plus, let's say 0.7 minus the second coordinate is 2 whole square. So how much you will get? Can anybody calculate? 4 minus 3 whole square plus 0.7 minus 2 whole square and its root over. What is the value we are going to get if you apply Euclidean distance? So 4 minus 3 is 1 square. So you will get 1 plus 0.7 minus 2. So this is 1. Okay. Plus this is, if you calculate, I can say it is minus 1.3 or 1.3. Both are same, right? 1.3 whole square and root over, right? Yeah. So if you see the value, you will get 1.64. You are correct. The value it is coming is 1.64. Similarly, you can calculate for other points. So I have given all the values here. If you see, these are the distance from our test pattern. P is equal to 3 and 2. So out of this test pattern, okay, sorry, out of these training patterns, the minimum distance we achieve here in the case of x16. Okay, once you calculate all the values, like you calculated this value is 1.64 and this value is 2.51. If you calculate all the distance, you will find the minimum distance you are getting in the case of x16. Okay, which is 1.12. What it indicates? It indicates that the pattern P is close to x16. So let us see in graph which one is x16. So you know x16 is this one, right? X16 is 3, 5, sorry 3.5 and 1, comma, its class level is 3. Class level 3 means it is represented in the form of star. So you can say, so it is 3.5, 3.5 is this one and 1. So this pattern, right? So the distance from our test pattern P to this x16 is minimum. Which one is 1 point? How much we got? 1.12, right? 1.12. Okay. So if you go to x16, if I write the pattern of x16, 3.5 represents x coordinate, 1.0 represents y coordinate, and 3 represents what? 3 represents the class level. So as the class level of x16 is 3, so the test pattern P, okay, class level is also 3. That means I can say it is classified as class 3. Okay. So in this way, the nearest neighbor algorithm finds one nearest neighbor, and based upon the nearest neighbor, that is x16 and its class level, its own class level is going to be decided. So it is a very simplest algorithm, right? Like if you want to take a particular decision, you are asking that opinion to your best friend, and your best friend is giving your opinion, and based upon that you are taking a decision, right? But there is a problem, right? Are if you are listening to only one opinion, so sometimes that opinion may not be a correct opinion. Okay, so in order to avoid that, people have come up with several variants of the nearest neighbor algorithm. So especially we are going to look into uh, four different variants of the nearest neighbor algorithm. We'll start with the KNN algorithm. So instead of selecting only one neighbor, we'll go for k different neighbor. Then we'll go for modified k neighbor algorithm, then fuzzy KNN algorithm, and R near neighbors algorithm. So let us see one by one. Yeah, as I mentioned, instead of finding one nearest neighbor in the previous algorithm, here we are considering k neighbors. Okay, but how many neighbors you are going to choose? It is very difficult to determine. So the value chosen for k is very crucial in our case. Again, many researchers suggested that the k value you should take is a odd number. The reason of odd number is that suppose if you are taking k is equal to even number, let it be 4. Okay, let's say two people are saying it is belongs to, let's say, class level 1, and another two people are saying class level 2. So there is a tie. Okay, but when you take k value as odd, okay, let's say odd value is I am taking 3. Okay, so let's say two people are saying it is class level 1, and one is saying class level 2. So obviously I'll go for class level 1. But if there are three class levels, okay, if there are three class level and you are getting an opinion like class 1 1, okay, class 2 1, and class 3 1, that is also very difficult. So based upon the number of class, okay, you can select an appropriate value. For example, here if I go for 5, okay, let's say another sample is coming here and the sample is coming here. Again, there is a tie, right? So that's why selection of a particular k value is very difficult. But we are taking generally odd number, because even number case there is a tie. Okay, and in odd number case also, if there is a tie, then you can increase the number of samples and find a particular solution. Okay, so now what we'll do, we'll take the same data set in which we have 18 different training patterns. Okay, here you can see 18 different training patterns which I have shown you earlier. So in every training patterns, the first value represents x coordinate, second value represents y coordinate, third value represents the class level, right? Now my training pattern, I am testing pattern is considered as 3 and 2. Okay, my testing pattern is considered as 3, 2. So this is my testing pattern in graph, right? So I have to find my nearest neighbor. I told you this is the first nearest neighbor. But as k value, I am taking here as 5. Okay, any value we can take, but as an illustration, I am taking the k value is equal to 5. So you have to find 5 different closest neighbor of this test pattern. Okay, so how to find? So we have already calculated the distance measure. And out of this distance measure, you have to find the 5 shortest distance. Okay, or 5 minimum distance. Best distance, next best distance, or like that, you have to go for 5 distance. So you can see out of all distance, I think the minimum value is 1.12, which we have already identified in nearest neighbor algorithm. Now, if you look into other values, this value is the next closest neighbor. So first one is it is x16. For p case, the closest neighbor is x16. Next is x7. Then you can get x14. Okay. Then you will get the next closest is x6, and next closest is x17. Okay. In fact, x6 and x17 can be selected in either way. Right? You may follow x6 followed by x17, or x17 followed by x6. right? Because you can see the distance is close, right? The distance is same. Yeah, x8 also. No, x8 case it is 1.44. Okay, so it is eliminated, right? If x8 value is also 1.41, then you need to consider, right? But x8 value is 1.44. That's why I'm not considering. So this is 1.12. This one is 1.13. This is 1.32. This one is 1.41. And this one is also 1.41. That's why I'm not considering x8. x8 is next closest, I think. Yeah, next closest is x8. And also we have x9 also. You can see 1.44. So this will come if I increase the k value to 7. I am taking k value as 5. So these two are not going to come. Right. Okay. So I have taken here x16. Okay. Let me go to this slide. So I am taking x16. Right. x16 followed by x16, then followed by x7, followed by x14, followed by x6 and x17 in any order, right? So if you go for x16, this is our x16, right? What is the class level of x16? It is 3. I am writing the class level. It is 3. What about x7? What is the class level? 2. x14, what is the class level? 3. x6, what is the class level? 2. x17, the class level is 3. Okay. So we found x16, x7, x14, x6, and x7, and we determine the class level. Now tell me, based upon the majority voting, if you go for majority class, which class we are going to assign to test pattern P? This is our test pattern P, which is 3, 2. Which class level we are going to assign? 3, right? Obviously 3, because 3 case 1, 2, 3. There are 3 votes. And for x7 and x6 case, they are class level 2, so we have 2 votes. So if you go for majority class of these 5 patterns, then class 3 is going to be assigned. Okay, however, this method will reduce error in classification. It is not completely eliminating the error, but it is am I audible?
Yes, sir.
Yeah. So we are not completely eliminating the error, okay? But in comparison to the nearest neighbor algorithm, okay, so we are eliminated the error up to some extent, as we are considering the majority classes here. So when your data set is a noisy data set, your training data set is noisy data set, in that case you can go for the k nearest neighbor algorithm. Okay. But there is also difficulties are there. So let us see this particular example. So here I am not taking the same data set. I am taking a different data set to show you what is the advantages of KNN, what is the disadvantages of KNN. Okay, now you will understand. So here this P is our test pattern. P is our test pattern, and this is a group of patterns belongs to a class. Let's say this is belongs to class X. X represents class X, class 1, and circle represents class 2. Okay. So the test pattern P is closest to which point? Let's say the closest to the point number 5. So anyhow, once the coordinate is given to you, then only you can determine whether P is close to 5 or P is close to 6 or P is close to 8. Okay. So assume that P is closest to 5. But if you look into this particular group, 5 is an outlier, right or not? 5 is an outlier. So outlier means what? Outlier is a abnormality, right? So all are more or less close to each other, but 5 is not that much close to everyone. 5 is only close to 4, we can say, but it is not close to 1, 2, 3. So it is considered as an outlier, right? Like I can say, in a particular class, you have given some set of questions, and you observe that none of them have means in your class. Let's say you have given 5 questions, okay, but most of the people solved only one question, but one student has solved 5 out of 5. So that can be considered as, okay, that can be considered as outlier or some kind of abnormality, right? So in this case, 5 is an outlier, right? So if you apply NN algorithm, so let's say 5 is the closest one, then NN will say that nearest neighbor algorithm will say that which one is closest. 5 is the closest of P. So P belongs to class level. P belongs to class level 1. But if you go for KNN algorithm, KNN algorithm will take a set of values as input, right? It is not dependent on only one value. So the point P will be classified to belongs to class 2. For example, if I take P, K value is equal to 3. So if I take these 3 value, 6 and 8, they are belong to class 2. 5 is belongs to class 1. Okay, 6 8 belongs to class 2, 5 is belongs to class 1. So we can say that P will be belongs to class 2 because majority class, if you look, it is class 2. So in that case, KNN is a advantages over the NN algorithm. But determining K value is experimental, or it is challenging, or it is crucial also, you can say. Okay, but KNN has solved this particular problem because NN assigned it based upon the class level of 5, but KNN assigned based upon the class level of 6 or 8. Okay, that in that way it is advantages over other algorithm. Now every algorithm has drawbacks. See, KNN also having a drawbacks, right? That you can see in other examples. Now again come back to this particular example, but here I am taking the pattern P is a different value. Earlier I am taking pattern P is equal to 3 and 2. But here I am taking now pattern is 4.2 and 1.8. Okay. So if P is 4.2, 1.8, again you have to find the nearest neighbor. So I have calculated the distance. Here you can see we have 18 points and P is 4.2 and 1.8. So we have calculated the distance of P to x1, P to x2 up to P to x18. Okay. So if you calculate this one, and let's say K value is equal to 1, means it is a nearest neighbor algorithm, right? If you go for nearest neighbor algorithm, the closest distance is x17. Okay. X17 is the closest distance, that is 0.82. If you go to x17, okay, x17 pattern, then okay, x17 pattern, then the class level is 3. Okay. So the pattern P also belongs to class level 3. Okay, because it is a nearest neighbor algorithm. But when you go for K nearest algorithm, instead of choosing a single neighbor, you have to take 5 neighbors if K is equal to 5. So these are the 5 values. X17 first, followed by let's say X11, sorry, X8, then X11, then X16, then X7. Right? So if I take this particular order, X17, X X X X17, yeah, X17 followed by X8 followed by X11, then X16 and X7. So we need to determine their class level. So I am determining their class level. One is X8, so go for X8. Okay, another is X16, so this is X16. Okay, this is X7 and this is X11. Now you see, if I go in I'll go in numeric order, it is X7, X8, X11, X16 and X17. So the class level of x7 is 2. Okay, the class level of x8 is 2. The class level of x11 is also 2. And the class level of x16 is 3. And the class level of x17 is also 3. Now you tell me, based upon the majority class, it belongs to which class? 2, right? Because 2 has majority. So P would be classified into class 2. So what is the difference you have seen? Earlier we have taken P is equal to 3 comma 2. So in that particular case, we observed that it belongs to class 3. But when I change the point to 4.218, again the value is changed. It is changed to the class level 2. Okay, so it depends upon the test pattern. Okay, and the nearest k neighbors, based upon that we can determine which class it should belongs, right? But whether when you take the five different calculations, like here you have calculated 5 different calculations. So the lowest distance you are getting in the case of x17, highest distance you are getting in the case of x7. But the importance of x17 and x7 is same, right? X17 also close to P, x7 is also close to P, right or not? So x7 is impacting P, x7 is also equally impacting P, which is not good to select a particular class level. That means if a particular pattern P is there, if somebody is very close to P and somebody is very far away from P, but the importance of these two are same, that is not correct, right? So that is the major drawbacks of KNN algorithm. So obviously NN has advantage over NN, KNN has so many advantages, right? But when you go for KNN, this type of problems is going to come. Okay, here there is a question that why are you considering 5 number of classes? So we are just taking 5 number of classes as an example. There is no bound of taking the what is the value of k. As I said, k value is experimental, and selecting the k value is also very difficult. So as an example, I am showing k value is 5. Okay. Yes, you can go for 7 and 9, but generally we take k value as a odd number. Whatever mentioned, you all are the odd numbers, right? But you should not take a even number, right? But you can take, like whenever we actually implement this in any machine learning and data science application, we normally try with k is equal to 3, 5, 7, 9, and so on. And we plot a graph. And from that graph, we observe that which value of k your performance is better. And we declare that that variable, that value of k is best for that particular data set. That's why I mentioned in my slide, k value is completely experimental. Okay. Okay. So in order to avoid the drawbacks of KNN algorithm, we go for another algorithm that is called as modified k nearest neighbor algorithm. So what we are doing in modified k nearest neighbor algorithm, why we need this particular algorithm? As I said, if you are taking 5 neighbors or 7 neighbors or 9 neighbors, all are equally important. But that is not true. So in order to avoid that, we have a modified k nearest algorithm. That means we will take k different neighbors, but the importance of k different neighbors are different. Okay, that's why it is also referred as distance weighted k nearest neighbor algorithm. We call it is by MKNN or distance weighted k nearest neighbor. That means every neighbor will get a distance. Okay, every neighbor will get a weight value based on the distance, right? For example, how to calculate this particular distance, that is more important. So each of the neighbor is associated with a weight W. So you are taking, let's say, I told you, k is equal to 5. So you are taking, let's say, 5 samples, x1, x2, x3, x4, x5. They are the closest for pattern P, but their weight values are different. Right? I can give a weight value 1 to x1, 2 to x2, 3 to x3, 4 to x4, and 5 to x5. So how to get this particular value, that depends upon this particular formula. Okay. So Let us understand this particular formula. What it says that Wj is equal to dk minus dj divided by dk minus d1. Okay. So this formula we are going to apply when dk is not equal to d1. So what is dk, what is dj, what is d1? I'll tell you with an example so that you can understand. Just imagine that, consider that dk is not equal to d1. It indicates that you will use this particular formula. And if dk is equal to d1, then the value is equal to 1. Okay. And this dj value will vary from 1, 2, 3 up to k. Okay. And the weight values you will get in the range of 0 to 1. Okay. So let us see. These weights of the representatives among the k nearest neighbors sum to the greatest value. Okay. That I'll show you through an example. So KNN says that you have to go for majority class, but MKNN says that you go for weighted majority class. Because when you calculate the weight value, like here they have weight, right? But their class levels are different. Like its class level is 2, its class level is 3, its class level is 2, it's 3, it's 3. So maximum of them belongs to class level 3. So KNN selects class level 3. But now what I'll do, I'll sum all the weights of class level 3. Alternatively, I'll sum all the weights of class level 2. Then what you will do? Then you have to find which class is having maximum weight. Okay. So based upon that, we are going to decide what is the class level of the test pattern. So let us see one example. Don't worry about this particular formula. Okay. Now, here I am taking the same data set which we have taken in very beginning. So there are 18 different patterns, and the test pattern P is equal to 3 and 2. Okay, test pattern P is equal to 3 and 2, and total number of training patterns that is given is 18. So if you find 5 nearest points, so you can apply Euclidean distance, which we have applied earlier also. So you will get x16, x7, x14, x6, and x17. These are the 5 nearest points, and they are sorted based upon their distance. That means x16 is very close to P, whereas x17 is far away from P, but it is coming under k is equal to 5. So now we have to, let me write here so that you can understand more clearly. P, x16, x7, x14, x6, and x17. Now we have to calculate the weight values for these pattern. So let's say the weight value of x16 is W16, it is W7, it is W14, it is W6, and it is W17. Okay. So W16, in order to calculate W16, you will use the formula dk minus dj divided by dk minus d1. Okay. Even if you see this particular formula where I said that dk is equal to d1. If dk is equal to d1, so I can write dk minus dj divided by dk minus d1, right? So dk minus d1. If dk is equal to d1, then what happens? The denominator becomes dk minus dk, right? That will be cancelled out. That is the reason why we make it 1. So in this case, dk is equal to d1. Okay, if you look into this one, in this case, dk is equal to d1. Then you will consider that value is 1. So what is dk? dk is the maximum distance. Out of these 5, which one is the maximum distance? That is your dk value. dj value is your current distance. Okay, and d1 is also your current distance. So in this case, if you apply the formula dk minus dj, even if you apply this formula, let us see dk minus d1. So I told you dk is the maximum distance over from the test pattern P, right? So the maximum distance is 1.41. So I'm writing 1.41. But what is the current distance? When you calculate W16, so your current distance is 1.12. divided by dk minus d1. dk is my 1.41 and d1 is the closest distance, that is 1.12, which is equal to 1. So in this case, dk is not equal to d1. Please make a note. I told you dk is equal to d1, but dk is not equal to d1. But numerator and denominator is same. So that's why the value we are getting is 1. So similarly, how to calculate W7? So note that these three values are same while we are calculating these three. Okay, 1.41, 1.41 in the denominator part and 1.12 in the denominator part. These three values are same for all the weight measure. So when you calculate W7, so I can say 1.41 minus the current distance is 1.13 and rest is 1.41 minus 1.12 in the denominator part, right? So you will get the weight value is 0.97. Similarly, when you calculate for X14, which is W14, W14 is 1.41, in the denominator is 1.41 minus 1.12, and the current for X14, the distance is 1.32. So I am putting 1.32 here. So we are getting the weight value as 0.31. Similarly, W6 case, which is for X6, so it is 1.41 minus 1.41 divided by 1.41 minus 1.12. Only we are changing this particular value because its distance is 1.41 here. Similarly, here also it is 1.41, so you will get the value is 0. So in this way, we are calculating the weight value of different neighbors. Is it clear? Is it clear how we are calculating the weight values? Yes. So note that dk is the maximum distance among these 5 points and d1 is the minimum distance over these 5 points. And one more thing, we are taking the current distance. Based upon that, you can calculate the weight value. But weight value we are not multiplying. What we are doing in this case, so let me clear this one. So W16 is 1, W7 is 0.97, W14 is 0.31, W6 is 0, and W17 is 0. So what is the class level of W16? W16 class level is 3. So I'm writing here, let's say 3. What is the class level of W7? W7 means it is X7, okay? So it is 2. W14 belongs to X14, right? So its class level is also 3. W6 case, 6 case, it is 2. And W17 case, we are getting the value is 3. So the class level of 3 samples is 3, right? And 2 sample is 2. So if you apply KNN, it belongs to class 3. But as you have considered the weight value, we are not going to consider based upon the class level. But now what you have to do, what is the how many of these neighbors are belongs to class 1? How many of these neighbors belongs to class 1? None of the neighbor, right? So out of this X16, X7, X14, X6 and X17, none of them belongs to class 1. So their weight value is 0, right? But when you go for class 2, how many of them belongs to class 2? W7 belongs to class 2? Yes, 2. W6 belongs to class 2. So what we'll do, we'll add these two values. That is 0.97 plus 0. So their aggregated value is 0.97. Similarly, when you go for class 3, okay, it is 1 plus 0.31 plus 0. So we are getting 1.31. So in this case, you can see maximum weight we are getting for class 3. Anyhow, in KNN also it is checking class 3. So as it is the maximum weight is 1.31, so we consider that the test pattern P belongs to class 3. Okay, but it is not always true, right? It is not always true. For example, assume that here you are getting a value, let's say 1.97. Let's say total is 1.9. Then will it belongs to class 2. Not necessary that if you have more number of neighbors belongs to the same class, uh, the test pattern belongs to that particular class. Sometimes with minimum number of patterns also, if your weight value is more, then you are going to assign to that particular class. So in this way, the test pattern P belongs to class 3. Is it clear how MKNN works? Okay. So, okay, if it is clear to you, now you can do one thing. Instead of taking P is equal to, in the previous one, I have taken P is equal to 3, 2. If I take P is equal to another value, so let it be the value of P is equal to 4.2 and 1.8. In another example, we have taken. So, can you calculate the weight value? So, if you calculate the weight value, first you calculate the distance. In distance, you got that these are the 5 nearest pattern. X17, X8, X11, X16, and X7. And I ordered them based upon the increasing order. So P, X17, X8, X11, X16, and X7. Right? Now, if I want to calculate the weight value, which I call as W17 and W8, W11, W16, and W7. So in order to calculate W17, what you will do? W7 is nothing but the maximum distance, that is 1.08, okay, minus dk minus the current distance is 0.83 divided by maximum distance minus minimum distance. So you will get 1. Similarly, if you calculate for W8, so I told you these three values are same, 1.08 minus 1.08 minus 0.83. Okay, for everyone, W11 case also 1.08 minus 1.08 minus 0.83. W16 case also 1.08 minus 1.08 minus 0.83. Similarly, W7 case also you can write like this, right? Only what you have to put? You have to put what is the current distance. So here I'll put 1.0 based upon this value. Next I'll put 1.02. Okay. Next I'll put 1.06. I'll put 1.08. Right? So now you got the weight values as 1, 0.32, 0.24, 0.08, and 0. And what are the class level of these 5 samples? X17, 3. X8, 2. X11, 2. X16, 3. X7, 2. So majority you are getting which case? Which class case you are getting majority? Second class, right? You can see 2 has 3 board and 3 has only 2 board. But we have to see the weight wise. So we have to sum the weight of X7. Okay. X7 is 2. X8. Another is X7, X8. Another one is X11. These three we have to add. How much you will get? You will get, yes, 0.56. But if you sum these values, right, that is 1 and 0.08, you will get 1.08. So see here only 2 neighbors are belongs to class 3, but 3 neighbors belongs to class 2. So if you go for KNN will assign this test pattern to class 2. But if you go for MKNN, then as maximum weights we are getting for class 3, so we are assigning it to class 3. The test pattern is assigned to class 3. Okay. So is it clear what I told you? So this is the only difference between the KNN algorithm and MK algorithm. So in the literature, most of the literature, if you go for, people have applied KNN. Okay, any algorithm. I'm not saying the fundamental research. Applied research, they have used KNN. So you can try with MKNN and you can see if there is a variation in your result. then you can contribute in that particular field. Okay. So yes, if you compare the two examples, example 4 and example 6, pattern P is classified as belonging to class 2. In example 4, using KNN with K is equal to 5. So it changes, right? Okay. Okay. So if you go for the another improvement over the KNN algorithm is fuzzy KNN algorithm. So fuzzy case we consider we are not saying that it is 0 and 1, but the value we are considering in between 0 and 1. Okay, you can say you have a membership value in one class, another membership value in another class. So that the elements of the set have a membership function attached to them, which is in the real unit interval, that is 0 and 1. So a new sample P has a membership that is mu I P for a class I, which is given by using this particular formula. It looks very complex, but it is very easy. Okay, so this mu ij, what it indicates? It indicates the membership of ith class of jth vector of the training set, and this m, the denominator, okay, m is a constant. Its value is provided by the user. Okay, normally we consider the value is equal to 2. So 2 minus 1 is equal to 1. So we don't consider the denominator, right? So each pattern has a membership of 1 to the class which the k, which the k, which that particular, if you look into the picture pictorially in the k nearest neighbor, if they belong to a particular class, their class level is 1. If they don't belong to a particular class, their class level is 0. Okay. And when you take for the test pattern, the test pattern is given a membership to every class, and the class which it has the highest membership value is the one it is assigned to. Okay. So based upon the membership values only, you have to determine whether it is belongs to a particular class or not. So let us take an example. So I am taking the same example which we discussed earlier. So I am taking the pattern is 3 and 2. And if you find the first 5 neighbor, you are getting x16, x7, x14, x6, and x17. Okay. So now we'll see the class level of this one. X16 class level is 3. X7 class level is 2. X14 class level is 3. And x6 class level is 2. And x17 class level is 3. Okay. So if you look into these 5 pattern, is there any pattern belongs to class 1? No. If no pattern belongs to class 1, the membership value of the pattern P belongs to the class 1 is 0. So out of 5 pattern, if none of the pattern is belongs to class 1, so there is no membership of the test pattern P in class 1. That's why we put 0. But there are some pattern belongs to class 2, right? So like if you see x16, x16 belongs to class 3. So its membership value, x16's membership value in class 3 is equal to 1, which we represent as mu ij is equal to 1. Okay, where I represent the class, j represent the vector. Similarly, x17 case, mu ij is equal to 1. Okay, but in the case of x7, x6, and x14, the membership variable value is equal to 1. For class, for x6 and x7, the membership value is 2. The membership variable for class 2 is equal to 1. Right? That means mu ij is equal to 1 for that particular class. Right? Means those points are explicitly belongs to a particular class. Their membership value is 1. But if you compare for other class, it is 0. like I mentioned here, class 2. So X6 and X7 belongs to class 2, so their membership value is 1. But other pattern, for example, X16 if I take, X14 I'll take, X17 I'll take, their membership value is 0. So if I consider M is equal to 2, so this denominator will vanish, like 2 minus 1 equal to 1. So if I calculate the membership value of the test pattern P belongs to class 2, so it is nothing but 1 by 1.41. Why I am taking 1.41? The distance of the pattern P to X6 is, I think, 1.41. Let us see. Yes, it is 1.41. Plus the distance from the pattern to, let's say, the pattern to X7 is 1.13. So you can see here it is 1 by 1.41 square plus 1 by 1.13 square, divided by all the values we have to write, because the minimum distance, if you remember, or you can see here, the minimum distance is 1.12, then 1.13, then 1.32, then 1.41, then 1.41. So in the denominator part, we'll keep 1.41 two times, 1.13, 1.12, and 1.32. You can see this one. So you will get the membership value is 0.406. Okay. Similarly, if you calculate the membership value in this case, what it indicates? Membership value of a pattern P belongs to class level 3. So class level 3, how many values are there? 3 values are there. So their distance is 1.12, 1.32, and 1.41 in different order maybe. Okay. So that we are taking in numerator, and denominator I am taking the same thing. So I am getting the membership value is 0.594. And note that sum of all the membership variable equal to 1. Okay. So if you see here, you are getting membership variable is more in the case of 3, right? That's why pattern P belongs to class level 3. Here you can see, as you are getting maximum membership value in the case of class level 3, so pattern P belongs to class level 3. Is it clear how to calculate the membership value and determine the class level? Okay. Now we'll go for the last variants of KNN algorithm before moving to the efficient algorithms. That is called as R near neighbor algorithm. Okay. So what we will do here, we can look at all neighbors with some distance R. So if I am taking a test pattern P, let's say this is the radius. Okay. So I'll take a radius. Again, selecting R is also very challenging, like K. So I'll take a radius and I'll find how many samples are, or how many data points are coming within the radius R. So the algorithm is given in 3 steps. Given the point P, determine the subset of the data. It is not necessary that when you take a radius, all the points will come. So we assume that it is a subset of data. In the worst case, the whole set will come. Determine the subset of data that lies in the ball of radius R centered at P. So using this formula we are doing. So if it is empty, then output of the majority class of the entire data set. We'll see the out of, let's say, 100 samples, 90 samples belongs to a particular class, we'll consider that one. But if it is not empty, then based upon the data points, we are going to determine the class level. Okay. So here I again mentioned the choice of the radius of R is crucial in this particular algorithm, right? So let us see this example. So I am taking the test pattern P is equal to 3 and 2, right? And I am taking the radius is 1.45. So radius is 1.45 means after calculating distance, you select the points whose distance is less than equal to 1.45. Here it is not less than, so I am removing. So these cases it is greater than 1.45, but this case is less than 1.45. Okay, so I am accepting this value. This is why I am discarding, discarding. This value I am discarding. This I am accepting because it is less than 1.45. This I am discarding. This I am accepting. This I am accepting, and this I am discarding. Okay, so you can see how many points are coming. 1, 2, 3, 4, 5, 6, 7. 7 points are coming. But if you look into that, x6 is 2, class level 2, x7 is 2, x8 is 2, x9 is 2, and x14 is 3, x16 is 3, sorry, x16 is 3, this is not the case, okay, and x17 is 3. So out of these 7, majority is belongs to class 2, right? That's why we consider that the class level of the pattern, okay, class level of the pattern is 3, sorry, 2, right? Because 4 sample belongs to 2. So in this way, we are going to determine the R nearest neighbor and determine the class level of a test pattern. So although these algorithms are again experimental, when you take a particular data set, like we took 2 data set, one is uh, glass identification data set, and another is wine data set. So in this data set, we applied all the algorithms and we developed a new variants of nearest neighbor algorithm, and we found that our variant is performing better in comparison to other variants. Okay. However, irrespective of the algorithm, you see it is a very time-consuming process, because when the training sample is, we took maximum of training sample of 18 in these examples, but when you go for real life examples, the number of training examples are very huge. So in that case, it is very much challenging, okay, to determine the nearest neighbor and doing these calculations. It's very complex job. So in order to avoid that, we have an algorithm. We have another set of algorithm. One is called as branch and bound algorithm. Another is cube algorithm, searching for the nearest neighbor by projection and ordered partition. So let us start the first algorithm. So one is called as branch and bound algorithm. So directly I'll show you an example. So what it says that it is based upon the concept of clustering. Okay. Or you can say it is based upon the labeled clustering. Labeled clustering is, you can say, it is a supervised learning. On-labeled clustering is called as unsupervised learning. So first, clustering of the points has to be carried out. Okay. Then what you have to do? Let the points of class 1 be taken from one cluster. Means those who are belongs to a particular class 1, they belongs to one cluster. So x1, x2, x3, x4, and x5, they belongs to class 1. Similarly, x6 to, I can say x6 to x12, they belongs to class 2, and the rest belongs to class 3. Okay, in this way we have made 3 different classes or 3 different groups or clusters. Now cluster 1 is divided into let's say subcluster. Cluster 2 is also divided into 2 subcluster. Cluster 3 can be divided into subcluster. Okay, we are going to divide it, right? That's why it is called as branching bound algorithm. So see here, these are the cluster 1 because the first 5 points belongs to class level 1. Next 8 points, 7 points belongs to cluster 2, and these points belongs to cluster 3. And I have divided into cluster 1A, 1B, 2A, 2B, and 3A, 3B. Okay. Then again, if you need, you can go for further division of the cluster. Okay. And how to do this one, you can see here. Like I mentioned here, mu1, R1, and B1, that you need to understand. So C1, 5 points are there in C1, right? I told you these are the 5 data points that are present in cluster 1. So if I calculate their, I can say average value. Okay, I am getting 1 in x coordinate, and y case also we are getting 1. So that is represented as mu1. Mu means average, right? So average of the group class 1 is 1, 1. Average of class 2 is 4.113. Average of class 3 is 3.62 and 0.72. Similarly, average of if there are more than 3 clusters, okay, in case of any other problem, you can find their mean value. Now you have to calculate the radius. R1 is considered here as 0.283, and R2 is considered as 369 and 0.528. Okay, this is the radius we have taken as an example. Now we left with another one, that is B1. So B1 is determined by D minus D of P and mu1, that is the distance of a test pattern P to mu1 minus R1. So R1 values are predetermined, or it is set during experimentation. Okay, so what we'll do here, if you calculate B1, distance of this particular test pattern to 1 1, because the mu1 is equal to 1 1. Okay, you will get the distance is 2.236 minus 0.283. So you will get the value as 1.953. Similarly, you can calculate B2 value and B3 value. Okay, and since out of this B value, okay, we found that B3 value is the smallest. So we decided that we are going to split the cluster 3 into two subclusters. Okay, means we have to divide the cluster into subclusters. Then we are going to search only the cluster level 3. Now, when you consider the cluster level 3, again you need to determine what is mu 3a, because under 3 you can see these are the patterns under 3, right? X13, 14, 15, 16, 17 and 18. So some patterns will go to cluster level 3a and some pattern will go to the cluster level 3b, and you have to determine this b. Okay, and radius is predetermined, or radius you have to guess, right? Some random values also you can take. So out of these, again you are finding the lowest value is cluster 3b. So cluster 3b is again further divided into two subcluster or three subcluster, right? But determining how many cluster level is also challenging, right? So like here I am dividing into 3 into. So we are going to carry out like this unless in the leaf level you have only one data point. Like here you can see I have 3 data points. Out of these data points, the minimum distance we are getting is 1.12. Okay, so that is considered as the minimum distance to the test pattern P. So based upon the test pattern, the X16 is class 3, we are going to determine the class level of the test pattern. Okay. Yeah, you can see the whole process I have written here. So what is the advantage? The advantage is that you can see under C3 you have 6 points. So you are comparing with only 6 points. Again, let's say out of 6 points, here it is 3, here it is 3. So you are only taking this particular node, then you are going for this particular node. So your search is reduced to 3. Again, you are picking only one particular node. So number of comparisons are reduced in the case of branch and bound algorithm. But previous case, what you are doing? You are calculating the distance to all the points, which is not good. So that's why this algorithm is said to be one of the efficient algorithm over the previous one. Okay, now come to the queue algorithm. So in queue algorithm, what you have to do, like here you can see there are two type of pattern I am using. One is class 1, which is represented as, let's say, cross, and class 2 is represented as circle. Okay, so 1 2 3 4 5 6 belongs to class 1, 7 to 12 belongs to class 2. And suppose I need to find k is equal to 5. Okay, let us say that k is equal to 5. So what I have to do, I have to select a window, right? For example, I am choosing the window size is in between, let's say 2 to 4. Okay, x-axis it is 2 to 4, y-axis is also it is 2 to 4. So this is my test pattern. Test pattern is represented as plus. So I am making a window. Again, selecting this window is also challenging, right? So if I put a window, how many samples are coming? 1, 2, 3. So what is my k value? K value I have assumed as 5, but it is coming as 3. So I have to take minimum of 5 values. Then I am expanding my window from 1.5 to 4.5, 1.5 to 4.5. So now you can see I am getting another 2 points, that is 4 and 9. So my k value is equal to 5 is satisfied. Okay, so earlier it is 3 points, but now it is increased to 5 points, out of which 4, 5, 6, 4, 5, 6 belong to class X, and 7 and 9 belongs to class 9. As 3 belongs to class 1, so Q algorithm says that you select as it is belongs to class 1. So the test pattern P is also going to be classified to class 1. But determining this cube length or expanding it to another level, like 2 we have increased to 1.5, again 4 is increased to 4.5. It is very difficult, right? So although if this technology, if this technique works, then it is an efficient technique over other techniques. So is it clear? If you have any doubt related to these two, you can ask. Branch and bound and Q algorithm. Okay. Then the third one is called searching for the nearest neighbor by projection. Okay. So what we will do here, in this case, I'm taking the same data set, and again the test pattern P is equal to 3.2. So here we order all the data points in the increasing order. What do you mean by increasing order here? The lowest increasing order means, for example, like here I am showing you an order that is x13, x14. Okay, so I am taking, let's say, x coordinate. Okay, let's say I am taking x coordinate of the test pattern, and I am taking x13's x coordinate. What is the distance? The distance is 0.2, and that is the minimum distance in x coordinate. Similarly, if I go for x14, x14 case, what is the x coordinate? Again 3.2, so it is also coming 0.2. Like that, based upon the x coordinate, I am taking only one feature. I am not taking multiple feature. So I have ordered them in a particular order. Now, once you determine this particular order, you write their distance. So x13 distance from P is 1.61. x14 distance is 1.32. Like that, I have ordered. This is not a sorted order. Sorted order base is based upon the x coordinate, right? So once you do this particular sequencing, what you have to do, okay, this is the calculation. If you want, you can go for it. So I'll start with the first point, that is x13. So starting from x13, the actual distance is checked and the minimum is noted. So the minimum distance in the case of x13, if I go, I'm getting in x13 case, the distance is 1.61, right? So I'm noting that now minimum distance I found is 1.61. So when I go for x14, the distance is 1.32. So 1.32 distance is better than 1.61. So I am selecting now x14. But when I go for x16, the distance is again reduced to 1.12. So I am noting the minimum is 1.12. But when I go for x7, the distance is now not decreased, the distance is increased. Okay, so when x16 is reached, the minimum distance is 1.2. But when you go for x7, it is also 1.2. When you go for x9, you will find again 1.12. Like that, if you carry out up to x18, you will find the minimum distance is 1.12. Okay, that's why we consider that x16 is the minimum distance, and as x16's class level is 3, so we consider the class level of class level of the test pattern P, that is 3 and 2, is class level 3. Okay, so as x16 is closest to P, we consider that is the class level. So in this way, the projection algorithm works. So it is based upon one particular feature. Somebody can take y features also. I'm not only considering the x coordinate. Somebody can consider y coordinate and make a projection, right? Now the last one which we are going to discuss, that is called as ordered partition. Okay, that is called as ordered partition. Yeah, there is a question. Sir, here data points are less, so clearly visible, but what is in the big data? No, you have to do the computation. That is correct. Whatever you are saying, when you do with a large amount of data, where your data points are in billion and million, or comparing is also very difficult, right? So in that case, you have to put a predetermined threshold rather than comparing with all the points. In fact, also you can see most of the systems which we are analyzing, Although we have billion and million data, our analysis is not done based upon the billion and million data. Our analysis is done with a set of data, right? Subset of the data. And whatever analysis we are getting with this subset, that is applicable to the entire data. Oh, you are asking about the threshold value. So I have not used any threshold value here in projection, but I have ordered them based upon this x coordinate. Okay, you can see this order we are finding based upon the x or the closest value based upon the x coordinate, because the x coordinate is here 3, right? So the closest one, if you check but the entire data set, you are getting x13 and x14. Okay, so the minimum distance wise, I have minimum x coordinate wise, I have sorted them in a particular order, and I am determining their distance value, and we are selecting a subset of point. We are not selecting all the points. So in that case, if you want to a threshold, if you want threshold, then we are setting a subset of point, not the entire set. And any threshold, any case, any particular threshold, determining the threshold is always a challenge. Which case we should go for x value and which case we should go for y value. It depends upon which feature is more importance. Right? X is a feature, y is a feature, as we are projecting in 2 dimension. But when we project in, let's say, n dimension, there n features are there. So you have to determine which feature is more important. So based upon that, you have to make a selection. Okay. So this is all about the projection algorithm. Obviously, if you are going for scanning also, where to stop? Like here you are getting 1.12 is minimum. We don't know, maybe after some point of time, we may get a value 1.11. So in that case, it is very challenging, right? But if you take a subset of value, you can make it possible by selecting the minimum distance. Okay, so the last one which we are going to discuss, that is called as ordered partition. So ordered partition, like here I have taken 12 points and my test pattern is 7, 7 and 7. Okay, 7, 7 and 7. So it is 3-dimensional, right? So what we are going to do is our pattern is P777. We source through a partition data. Partition data means, suppose I am partitioning the data into 3 parts. I am saying minus infinity to 2.5 is one, 2.5 to 4.5 is another one, and 4.5 to 7 or plus infinity is another one. What is the meaning of this one? The meaning is that if the x coordinate value is up to 2.5, then they belongs to partition number 1. So you can see all the values, okay, all these values are of these 4 different data patterns are less than or equal to 2.5. So they belongs to this particular partition. Again, partition is also challenging. You may ask how to make a partition. So there is no specific answer for the how to make a partition. You have to put some condition and do it. Okay. Now, if you see these samples, their x coordinate lies in between 2.5 to 4.5. And these 4 points belongs to 4.5 to 7. Again, you have to make another partition. Like here I can say, if the values are in between -8 to 1.5, they belongs to x1, x3. So maybe I am targeting here the another coordinate. For example, here you are targeting x coordinate, but I am now targeting, let's say, y coordinate. Y coordinate, the maximum value is 3, right? So I have split it in. If the value is minus infinity to 1.5, then that belongs to this subpartition. And if it is 1.5 to 3, this belongs to another partition. But in this case, as we are taking a very small data set, some values may not come also, right? Some cases you may get only one value also. Like that, a subpartition is again further divided into sub-subpartitions. So like that, if you go for the leaf level, right? If you go for the leaf level of this ordered partition, you will get only a single value. So what we are going to do, whenever you are going for choosing a test pattern, okay, if you are going to choose a test pattern, so first you will see the first feature is 7. So 7 belongs to this particular partition. Then let's say next is also 7. This belongs to this particular subpartition. Again, it belongs to 7. Okay, so 7 is close to 6.5. Then I can consider this is the closest one. So how many matches we are doing? We are doing only 1, 2, 3 matches to reach a particular value. So when we do with a large data set, so generally these efficient algorithms are applied to find the class level of any pattern. Okay, so x11 is chosen as the closest point to that point, and x11 belongs to, I think, let's say class level, let's say 3. So it is also belongs to class level 3. So in this way, we are going to determine it. Is it clear? Okay. So as a conclusion, I can say we have started with the nearest neighbor algorithm, and we have seen 4 variants of the nearest neighbor algorithm: KNN, MKNN, Fuzzy KNN, and our nearest neighbor algorithm. And we have seen 4 efficient algorithm, that is branch and bound algorithm, queue algorithm, searching for the nearest neighbor by projection, and ordered partition. And if you want to go for more details about this, you can refer this particular book by Professor Susila Devi, and book name is Pattern Recognition and Introduction. It's a very nice book if you are interested in machine learning and data science.